Hi, everybody. Welcome to the Off-Chain Code Beginner Web3. Today is actually not November 16th, but it is lesson 7. So today we're going to be talking about loops. Loops are used all throughout programming in all types of languages. So we're going to try to dive in both with some Solidity examples at the very beginning, just to kind of give an idea of what it actually looks like when we get into smart contracts, but also diving more into the JavaScript side as a basic introduction to how loops in programming work. So before we get into that, a little bit about off-chain. If you guys have not joined into the WhatsApp, Telegram, or checked out our website, these are some of the QR codes you can scan and check it out. I recommend going off to offchain.social first on the website. You can see all the different groups. It's a great place to meet other people that are interested in blockchain or Web3 technology local to your city. And I think that's a great way of meeting others and getting to know more about this space. A little bit about myself. I've been living in Guangzhou, China for the past 3.5 years, but I actually have some very exciting news. As of this week, I've officially moved from Guangzhou to Shanghai, China. So I'm really excited to be doing my first presentation from Shanghai. I've been working for the last few years now at an international bank as a software developer. And I previously worked as a chief technology officer on many different development and love to travel around the world. So this course is not designed to make you a professional developer, but it is designed to give you an introduction to how Web3 technologies work. So let's get right on into it. Lesson 7, loops. So loops within Solidity is actually what I'm going to first show, because this is Web3 and we're probably all interested in how the smart contracts work. So within the Solidity code, what a loop would look like is actually, well, very similar to what you're going to see in JavaScript. And I know this looks overwhelming, but I really enjoy looking at real life examples rather than just saying, here's a very basic one. So don't get overwhelmed. It looks like a lot of code, but we're going to break it apart. A loop is effectively how you can iterate over something multiple times. So rather than having to write it out multiple times, we can use the loop as a way to be able to repeat ourselves. So take a look at the first thing on the left, function, C token, metadata all. I took this Solidity directly from Compound.finance, which is one of the most popular DeFi applications. They're using this particular function, C token metadata all, as a way of capturing all the metadata on all of the different tokens that they have within their platform. Let's go ahead and take a look at their platform first, and it'll make a bit more sense. When you look at Compound, this is a DeFi lending platform where people can lend out their tokens and then people can borrow it. Because they support many different tokens, each of these, when they get borrowed or lent on out, derives what are called C tokens. They take the original token and they say, okay, in exchange for giving us some liquidity, we're going to give you back a C token. In order to come up with all this pricing information about, okay, what's the interest rate and how much supply and demand does all these have, all these numbers are actually tracked on the blockchain. And rather than requesting from the blockchain each of these numbers every time somebody goes to this Compound app, what they do is they say, I have an interest in all these particular tokens, go fetch the latest information. So in order to do that, they loop. On the right-hand side is the function call that they make to get all the information. You can see this function call in Solidity. It's going to return this list of memory, as they call it, C token metadata memory. We don't have to pay attention to all this code. Basically, the thing of interest is it's going to return this giant object of what is the token, what is the current exchange rate, what's the supply buy rate, borrow rate, reserve, total borrows. All this information is exactly the information that they use throughout their app. Now, it's perfectly possible to recall this function one at a time. So if I was interested in the OV token metadata that's presented on this picture here, I could just pass in to this function, the OV token information, and it would spit out this blob of data, which I could then use to populate the supply rate, the distribution APY, borrow limits, etc., that are used on this page. But it would be pretty tedious if I had not just one token, but like hundreds of tokens, which they support. As you can see on this page, there are many, many, many tokens that they need to go fetch this information on. So to make it more efficient, we use a loop. The loop is right here. For uint I equals 0, I is less than C token count I plus plus. What in the world is that? Well, today we're going to take a look at what does this for loop mean and how do I decipher what these things are trying to tell me here. It looks pretty foreign right now, but once you've gone through a few of these examples, a lot of programming languages implement loops very, very similar to what we're seeing here. What this is Solidity code. And what we're about to go see next is going to be JavaScript code. And it's pretty remarkable, almost how identical these two languages are. There's just some very slight differences in this for loop. So again, loops are a way to express something that you could write out manually. We could manually go type in getting the metadata for each one of these different tokens. But instead, what they've done is they've passed in an array of tokens they're interested in, and they're able to iterate over that array to go fetch all that information to get the information for the screen. All right, we'll come back to the Solidity part, but let's go take the JavaScript and try to make some sense of this. It's a lot of information to take in at first. So we need to do some examples. Go to Code Academy and go to lesson 7. In this lesson, we're going to cover the loops. Now we're going to be switching over to JavaScript, but again, it's going to look pretty similar. So a loop is a programming tool that repeats a set of instructions until a specified condition called a stopping condition. So as a programmer, you're going to find that you rely on loops all the time. And it's actually interesting. They say that, but in blockchain applications, we tend to try to avoid loops as much as possible because, well, the more you loop over something, the more gas you have to use. But it is true, you're going to hit loops quite a lot. So we often call this process iterating. So when you loop, you might also interchangeably use the word iterate. It just means to repeat something. Why do we do this? Well, it simplifies our code so that we can reuse a task often. And if we have to do it multiple times, then it's often advisable to do it in a loop. So the example they gave here is we start at, are you hungry? And if you are hungry, then go eat. Then you have a stop condition. Are you full? If yes, then done. But if you're not full yet, meaning you're still hungry, you should keep eating. And we just continue in this cycle over and over and over. So let's go try an example. Repeating tasks manually. So before we write our own loops, let's do it the old-fashioned way. Let's try to do it manually. That's pretty tedious, but it emphasizes the point. So the first instruction they want us to do is to take a vacation spot. So we're going to create a variable vacation spots. So remember, to create a variable, one way of doing it is to use the let, and then they wanted to call it vacation spots. They say assign it to an array of 3 strings, naming the places you'd like to visit. All right, so to assign it, we use the equal sign. If we recall the arrays lesson, we use the brackets. To give it 3 places, places would be an example of a string. So we'll use 3 different strings. I would like to go visit Qinghai, Liaoning, and Tibet. Maybe not your traditional vacation spots, but these sound pretty fun to me. We're going to go run that. Great. In the next one, it's saying console.log each item in vacation spots. Since we don't know the loops yet, we have to console.log each element in the array separately. Man, that is such a boring way of doing it, but let's do it. Console.log. So if we want to print out the first vacation spots, well, it's going to be vacation spots. Recall back to how to access elements of an array. We have to use the bracket, and then we have to pass in which index do we want to do. One manual way of doing it would be to say the first index, meaning the 0th element. Remember, we start from 0 with arrays. Well, that would be the first one. And to do the next one manually, we'd have to type it in all over again. Vacation spots. To get to the next one, 1. And the last one, oops, if I could type correctly. And there we go, more or less. That's good enough. Let's write it on out. There they are. Qinghai, Liaoning, Tibet. Nice work. Okay. Then your boss comes along and says, great, print out 100 of them. And you say, what the heck? There's got to be a better way than typing out 100 of these. Now, don't get me wrong. When you start off as an introductory programmer, I've come across a lot of times that somebody just starts coming on in and they start doing this and this and this and this. And it's like, come on, guys. Like, no. We don't do that. Instead, we use loops. So let's go see how we can make a loop that does what we just did here in an automated way. The most common one is the for loop. And just like we saw in Solidity, you can do it in JavaScript too. So the typical for loop is an iterator variable that usually appears in all three expressions. The iterator variable is initialized, then it's checked against the stopping condition, and then it's assigned a new value on each iteration. So those are the three things that are in the for loop. The iterator variable needs to be initialized. We then check against the stopping condition. And then the final part is we assign a new value on each loop iteration. In fact, this is how it works in JavaScript. This is also how it works in Solidity. And just about every programming language I've ever come across, it's going to be very similar. You're going to initialize that variable, you're going to find a stopping condition, and then you're going to do what you need to do next with that variable to iterate. Iterator variables can have any name, but it's a best practice to use a descriptive variable name. Remember, going back to variables lesson, you can call the variable, I123, but that's a pretty terrible variable name because it doesn't really mean anything. So as a best practice, try to avoid very short variable names because, well, it won't help the next programmer figure out what you're talking about. In JavaScript, we separate those three different sections with a semicolon. Why? I don't know. It's just the notation that everybody seems to do. So just memorize it. So here's an example. For, meaning that we're doing a for loop. The loop is then put into this set of parentheses. And you'll see that it's separated into three sections separated by semicolons. The first section initializes a variable. So in this case, they're letting counter equal 0. In the second section, they're setting the stopping condition, counter less than 4. In the last and third section, we have an iteration statement saying, okay, on the next loop, what should we do differently? In this case, they're taking the initialization counter and they're plus plus. If you recall back, plus plus will add 1 to the original variable. So in this case, we're going to start at 0. We're going to keep going until we are less than 4, not equal to 4, but less than 4. And each time we loop, we're going to add 1 to counter. During this loop, console.log is going to print out what is the counter. So on the first pass, we would expect it to be set to 0, so it would print out 0. It's then going to complete that loop and add 1. Counter is now 1. 1 is less than 4, so it continues to run again. Console.log, it's going to print 1. Then it adds another 1 to 1. We're now at 2. 2 is less than 4. So we print out 2, and we then print out 3. And then finally, we're now at a point where it's going to go counter plus plus on 3, which will now be 4. Because 4 is not less than 4. 4 is equal to 4. It is now done. It will not print out the number 4 because it has hit the stopping condition. So just as we described, we would expect to see 0, 1, 2, 3. Be very careful on stopping conditions and be very careful on where you initialize your counter. As well, make sure you use something that makes sense for these iteration statements. Let's give some examples here. Now make your own. Create a program that loops from the number 5 to the number 10 and logs each number to the console. All right. For, since we're doing a for loop, we should then create a new variable. We can call it counter again. Now, in this case, we want to start from the number 5. So it's not a bad idea to just let counter equal 5. It's one way of doing it. There are many ways. Now, we need to make sure that we print out from 5 to 10, meaning 10 is inclusive. We need to see the number 10. So we can do counter is less than. There's a couple ways you can do this. You could say less than 11. That would work because 10 is less than 11 and it'll include it. But probably the better way of describing it would be less than equal to 10, meaning when you get to 10, do print out 10, but do not print out 11. Finally, we need to say what we're doing. So it's counting from 5 to 10. Now, they didn't really specify, but I'm assuming they meant integers, not, every single possible number that's in between 5 and 10. That'd be infinite numbers, but let's just assume they meant integers. And therefore, we'll take counter and we'll add plus plus. So in this loop, they want us to console.log because we're logging it out to the here. And from here, we're going to console.log the counter. Okay, let's give it a shot. Run. 5, 6, 7, 8, 9, 10. Good. We've successfully printed out from 5 to 10. Watch what happens if we break it, though. If you forgot the equal sign, what you'll get is that it'll stop at 9 because 10 is not less than 10. You must include that equal sign. If you forget the plus plus, watch what happens. It's running. It's running. In fact, it'll run forever. This will never end. Why? Because what's happening is it's letting 5 as the initialization. Then it says, is 5 less than or equal to 10? And it'll console.log the 5. And finally, it did end, but all we got to was 5. In fact, an infinite number of 5s. Now, luckily, it timed out. Luckily, our browser said, please stop running. This is never going to complete. It, in fact, it never shows an error, but you can see it took a really long time to go run, and it has a ton of 5s being printed out. Your browser is smart enough to know that if a program runs very, very long, it should probably just break it. And so that's normally what will happen is your browser will start to time out. It'll then say, do you want to wait for this page or do you want to kill it? So that's not necessarily always going to happen with all programming languages. In fact, if this was Solidity, you wouldn't time out. What you would do is a different type of halting condition. It's called running out of gas. Remember, everything on a smart contract requires some gas to go process that instruction. And as a result of going in an infinite loop, you can be quite sure, unless you had an infinite amount of tokens, you're going to run out of gas. And that's a good thing because it prevents the blockchain from seizing up and not being able to process a future transaction. So make sure you've got that iterator statement correct. And there you go. Let's go to the next exercise. There's no need to go forward. You can, in fact, go backwards. So let's talk about looping in reverse. What if you wanted to log out 3, 2, 1, and 0? We can go backwards. Let's give it a shot. Make a for loop that loops backwards, printing 3 to 0 from the console. So the loop below loops from 0 to 3. Edit it to loop backwards from 3 to 0. They want us to use the greater than or equals comparison operator in your stopping condition and the minus minus operator in your iteration statement. All right, remember, the comparison operator is going to be here in the stopping condition. And the operator on the iterator statement is right here. So since we want to count from 3 to 0, or sorry, yeah, we want to count from 3 to 0, we should probably start the counter at 3. That makes sense. Now, we want it to get to 0, and it wants us to print the 0. So one way of doing it, and in fact, the way they want us to do it, is to greater than and equal to 0. So we're saying from 3, as long as it's bigger than 0 or 0, keep running. Now, in order to make it go down instead of up, all we have to do is instead of plus plus, minus minus. This will now subtract 1 from the counter on each iteration. 3, 2, 1, 0. Again, if you forget the equal sign, it won't print the 0 case. So make sure you're setting the stopping condition to be exactly what you want. If you put the minus minus in front of the counter, interesting. It'll also do the same thing. But general notation, minus minus. Cover that later. All right, next. So loops are handy iterating over data structures. For example, we can use a for loop to perform the same operations on each element on an array. Arrays hold lists of data like customer names or product information. Imagine we owned a store and wanted to increase the product of every product in our catalog. You could give it to the intern to go say, please go into each single one and go increase that. But the intern's not going to be very happy. And if the intern's any bit smart, they're going to break out some JavaScript and do it in code. So the way they're going to likely want to do it is by writing a little bit of code, because while it's easy enough if you only have, a few items in your catalog, if you had thousands or hundreds of thousands, or your, Alibaba or Amazon, you might have millions or billions of different types of items. Definitely not possible to do this manually. So this is where code really comes into play. Machines are very good at repeating things over and over and over again. So here's another example. Check out the example below for how for loops can iterate on an array. Imagine we have a list of animals in an array. So grizzly bear, sloth, and sea lion. If we want to print out each animal, we can use an index called I, set it to 0 because the first element's always 0, and say why I, the index, is less than the animals.length. Remember, arrays have a built-in property called length. When we look at this array, if you call the dot length, it's going to get 1, 2, 3. So rather than typing in and hard coding the number 3, you'll see that I is less than 3. We can use animals.length to programmatically figure out what it is. This is a better way of doing things because if we add another animal, we no longer have to manually update our code. It'll automatically make sure that we've included that animal in our length. I++. So it's going to print out grizzly bear, sloth, sea lion. All right, let's try an example. Write a for loop that iterates through our vacation spots array using I as the iterator variable. So they have vacation spots. Well, they pick some more interesting ones: Bali, Paris, and Tulum. So they want us to print it out. And in this example, they want to say, I would love to visit, and then the vacation spot. Okay. So let's write our for loop for parentheses. Remember, the first thing we need to do is have an iterator variable. In this case, they're giving us an example that they want us to use I as the variable. I personally don't like using I because it can become very confusing. But that being said, let's do it. Let I equal 0. Why 0? Because we want to iterate over this array, and the 0 element is the first element. We then say we need a stopping condition. So we put a semicolon down. Our stopping condition needs to be when we get to the end of the array. So I must be less than the end of the array. Well, the array is called vacation spots, and the end of it is the length. Remember, vacation spots.length is going to return 1, 2, 3. A length of an array starts from 1. This gets very confusing. Even though the index of the array starts at 0, 1, 2, the length is going to be 3. This works out quite well. A common mistake is you might get confused between the length and the index, and a lot of students will accidentally subtract 1. This will get you a total of 2, meaning that you're only going to print out Bali and Paris. So be careful of that mistake. That would be wrong. The length is what we want to use, as long as we do less than. I is less than length, meaning we'll never actually get to the third index. There is no third index. That would be out here. We'll be below it. And each time that we go through this loop, we want to go to the next one. We want to go to the next index. So we take our index, I, we need to go to the next one, so plus plus. Now, we've completed our for loop. We just have to say, what do you want to do each time you run this for loop? We put the curly brackets down, and now we start to declare in this block, what do you want to do? It's telling us we're supposed to print things out, console.log, and it's saying we should print out a string, console.log, I would like to visit. You can put a space down, and that, and then we'll put a plus sign to join together our vacation spots. And then at what index are we? Index I. Let's run it. I would like to visit Bali. I would like to visit Paris. I would like to visit Tulum. As you can see, each time it runs, it's using the index to figure out which one of these 3 elements to go do, until it hits length 3, in which case 3 is not less than 3, therefore it stops. At that point, it will be down here. You could put down below this, down here, I am done. You'll see that I am done only runs once it's completed all the loops. If, however, you accidentally put I am done inside the loop, you're going to get it running 3 different times. Be careful about this block of code here. This is the thing that's going to run multiple times. So only put its stuff inside here that you want to run each time you iterate. Put everything that you want after you're done iterating outside the block of code. The other thing you should be careful about is your I variable is very sensitive. What happens if you accidentally do something to your I variable inside the code, like I++? What in the world just happened? It only ran twice. I love Bali. I love Tulum. What happened to Paris? We skipped Paris. Why? Because you modified your iterator variable inside the iteration block. This is usually pretty dangerous. You probably didn't mean to do that. Be careful about doing stuff with your iterator variable other than just using it. Under most for loop conditions, you probably don't want to modify your iterator variable inside. And if you accidentally do, it can make very, very tricky to troubleshoot. In this case, it's pretty obvious, but imagine you had a very long block of code and you accidentally modified I. Debugging it can be a real pain to figure out where things went wrong. All right, nested loops. So you like loops, how about loops within loops? A nested loop is when you have a loop running inside another loop. And that's pretty simple to understand. We use nested loops to compare elements in 2 arrays. For example, for each round of the outer for loop and in the inner for loop will run completely. Let's look at this example here. Imagine you have 2 arrays, my array 6, 19, 20, and your array 19, 81, 2. On the outer loop, they set this loop for I equals 0, I less than my array.length, I++. We can see just from that statement, it's going to iterate over my array. But then immediately after they get inside the block of code, they start another loop. They're doing the exact same thing, but they're using a different counter called J, also set to 0, and they're now iterating over your array, 1981-2. And for each time that they iterate inside these loops, they increment I++, and within this loop, they're incrementing J++. Inside the inner loop, they're then doing a conditional statement. If my array at position I equals your array at position J, both loops have the same number, and then it prints out the number. So what's going to happen? 6 is going to first come on up because that's the outer loop. It's at 0. It's then going to drop on into the inner loop, J, at position 0, 19. So is my array 6 equal to your array 19? No, it's not. So it won't print out this information because they're not equal. It's then going to go back to the inner loop, not the outer loop yet, because we still have more numbers to evaluate in your array. Your array now goes to index 1. We now look at 81, and we say, is 6 equals 81? No. So it's going to go back again to the inner loop. Is 6 equal to 2? No. At this point, we are now past the length of your array. It's done. There's no more numbers in your array. We've completed it. So we now go back to the outer loop. Previously, we were at index 0, but because we're now I++, we now go to I1. Now we have 19, and we repeat the same process all over again with your array. Is 19 equal to, well, J equals 0, 19. Yes, it is. So the console.log is going to print out both loops have the number 19. Is 19 equal to 81? No. Is 19 equal to 2? No. Then we go back to the outer loop. Is 20 equal to 19? No. Is 20 equal to 81? No. Is 20 equal to 2? No. So the only thing that would print out from all of that work would be the single 19 does equal 19. Both loops have the number 19. Let's give that a shot. Imagine you're a bigwig programmer for a social media platform. You've been tasked with the following: build a prototype for a mutual followers program, meaning both people from 2 different people have the same friend. So you'll need 2 arrays of friends from 2 mock users that can extract the names of followers who exist in both lists. So they want us to create a variable called Bob's followers, and set it equal to an array with 4 strings equal to the names of Bob's friends. All right, so Bob is friends with Zhao. Bob is friends with Joe. Bob is friends with Mary. And Bob is friends with Zhang. Those are 4 different friends. Make a variable called Tina's followers. Let Tina's followers, and set it equal to an array with 3 strings representing the name of Tina's friends. Make 2 of these 3 strings the same as Bob's followers array. All right, so let's say Tina is friends with, I don't know, Christy, but she's also friends with 2 of the friends of Bob's. We'll say Mary and John. Okay. Create a third variable called mutual followers and set it to an empty array. Let mutual followers equal to empty array is just 2 brackets. All right, create a nested loop that iterates through Bob's followers as the array for the outer loop and Tina's followers as the array for the inner loop. If the current element from the outer loop is the same as the current element from the inner loop, push that element into the mutual followers array. So we want to find out which of Bob's followers are also Tina's followers. And if we find any of them, we're going to push them into a new array called mutual followers. This will require a nested for loop. We'll do a for loop on the outer for Bob's followers. So we'll say we can do I equals 0, where I is less than Bob's followers dot length. That should iterate over the entire length of Bob's followers. And for each time that we iterate, we want to increase I by 1. Since it's a nested array, we also need to loop over Tina's followers. For let another counter. Don't use I because I is being used for Bob. So we can use J equals 0 to start at the beginning, where J is less than Tina's followers dot length. Again, we want to increment the counter for Tina's followers. Don't use I. We're counting with J for Tina. So J plus plus. We then put another code block. Each time that we increment over Tina's followers, we now want to check, are they the same? So we have to do if Bob's followers at the current position should be measured by I, equals, that's 3 equal signs, Tina's followers at its current position. We measured Tina's index with the letter J. If they happen to be equal, then we found a match. What do we do with the match? We take the mutual followers array and we want to add a new element to it. One way to do that is to push it on. Arrays have a built-in method called .push that we covered. We could .push and pass in the thing that we just found, Tina's followers at position J. It is totally fine to also do mutual followers .push Bob's followers at position I, because we just found out they're equal. You could do it either way. Doesn't make a difference. It's the same name. We just proved it based on this conditional statement on line 10. Either way is fine. All right, we just found it. That's it. We now have something that is commonly used to be able to do matching. It's going to need to loop over both arrays and find out where all the matches are. You could then at the end of this do console.log mutual followers and see what's inside. Marian Zhang. Look at that. That's pretty cool. We're able to take an arbitrary length array and another arbitrary length array and now find matching elements. This is a very powerful concept because while it's pretty easy to see that Marian Zhang we're going to match up, if we had, millions of followers for Bob and, another million different followers mostly for Tina, it'd be very difficult for any human to go do this. But for a computer, this is a very simple concept and something that you can repeat very quickly. So that is a nested array. 2 for loops, each with its own counter, its own stopping condition, and its own way of incrementing, looping over each one of these arrays and looking for a condition to then go and add it to a new variable. So we've been mostly talking about here for loops, but there are different types of loops. Another type of common loop that I see is while loops, and Solidity and JavaScript both have this. It's just a different way of expressing the same thing. In fact, anything that could be done as a for loop actually can also be done expressed as a while loop. So you can actually turn a for loop into a while loop and a while loop back into a for loop. It's just the same thing, but just expressed a little differently. So with a for loop, you've got three sections: the incrementer, where you define it. You've got the stopping condition, and then each time you're iterating. A while loop, though, is set up with just the stopping condition. What it assumes then is that somewhere outside of the while loop, you've already set what the incrementer is. And inside the loop, you then have to account for any incrementing inside the loop. It's the exact same thing. What you see up above here does the exact same thing as down below here. All right. It's a lot of words here. Let's just try it. To do a while loop is quite simple. Below the cards array, declare a variable current card. Okay, so let current card, but don't assign it a variable. Well, that's easy. Let current card. Okay, we now have a current card, but it has nothing in it. Now it's asking us create a while loop with a condition that checks if the current card does not have a value spade. All right, so I can see that cards can either be diamonds, spades, hearts, or club. It's look for when it's not a spade. Okay, so while loops again work on the idea that you just put in the stopping condition. So it's saying current card should not be equal to spade. That's when we want to stop. If we don't hit that stopping condition, we run this block of code. Inside of the block of your while loop, add the following line of code. Okay, this is confusing. Let's take it slow. Current card is going to get set equal to cards. Cards is this variable up here, diamond, spade, heart, club, at the index of math.floor. What? Okay, let's talk through this. Math.random, meaning a random number, times 4, end parentheses, end bracket, end statement. What in the world did we just do there? Let's start from the inside. Math.random is going to return a random number. We're then going to multiply a random number times 4. This will give us a random number from 0 to 3. That is very useful because it happens that 0 to 3 means it's going to pick one of these indexes, 0, 1, 2, or 3. So it's basically like choose a card, any card. Once you choose a card, it's then going to see what is the current card. Current card will be one of these 4 different types here. The while loop then keeps running and running and running, in theory forever, but we know statistically it won't run forever. Eventually, with a 25% chance, it's going to pick a spade. And when it does, it's going to stop running. But it doesn't guarantee that it'll ever run out of cards. In theory, it could run forever. Let's run it. Well, it ran, but we can't see anything. Why? Because it kept picking cards, but it actually didn't print out anything. So the next step here is let's add a console.log statement to our while block so we can actually see what's happening. Console.log, and then let's print out the current card. Let's run it. Well, that was pretty unlucky. We picked spade literally on the first one. So after picking a spade, it then said current card spade not equal to spade. No, it most definitely is a spade. Stop. Okay, well, that's pretty boring. Let's run it again. As you can see, math.random returned a different random number each time. And in fact, The first time we picked a diamond, then we picked a heart, then we picked a club and a heart, and then finally we picked a spade. At the point that we hit a spade, the while loop then said, is spade not equal to spade? No, it is equal, therefore stop running. So we can keep running this over and over and over and over. You'll see that each time we're running it, because we're doing the math.random, it's non-deterministic, meaning you can't predict what it's going to go do. It will generate a different number each time. This is actually pretty interesting because random numbers are something we haven't talked about, but are very important in computers because, well, sometimes you need to be able to just do something which you think is random. It's actually not quite random, but it's random enough that we couldn't predict it easily. In a blockchain application, we don't tend to do things randomly. In fact, we have to make things deterministic, or when everybody's evaluating the blockchain, people will come up with different answers. And that's a bad thing because then we can't agree. And if we don't agree, well, then the blockchain stops. We can't process the next number. But in JavaScript, random numbers are pretty useful. Imagine this was a game and you wanted to place a bet. You could easily make a betting game out of this to say, what are the chances that you're going to pick a spade? And you could use that to be able to calculate the odds. Okay. Let's go to the next exercise. There's another type of while loop, which is a do while statements. In some cases, you want to run a piece of code at least once and then loop based on a specific condition after its initial run. This is where the do while statement comes in. A do while statement says to do a task once and then keep doing it until a specified condition is no longer met. The syntax for a do while statement looks like this. Let count string equal to nothing. Let I equal to 0. Do something. Count string is now going to equal count string plus I. So in this case, nothing as a string plus 0 is going to equal to count string. So we'll store that back on into count string. We then increment I by 1. So now I is equal to 1 and count string is equal to 0. So let's see what would happen. So we can try this on out. Let's just copy and paste and try it in this example. Run. What you see is 0, 1, 2, 3, 4, because each time it runs, 0 gets appended onto the count string, and we store it in here, and then we keep looping until I is less than 5. We don't print out 5 because the while statement hits 5 and says 5 is not less than 5, therefore it stops, at which point it prints out a giant string of numbers 0, 1, 2, 3, 4. Let's try the next one. First message, I will print. Second message, I will not print. A do while statement with a stopping condition that evaluates to false. So do something, console.log first message. It's going to print out, I will print. While true equals false. Well, what's it going to do? True is definitely not ever false. So let's see. I will print. So it will print out the first thing, but then it'll stop immediately because, well, true is not equal to false. So it will never get to the second message. On this one though, a while loop with a stopping condition that evaluates to false. While true is equal to false, well, that's never going to happen. So it never prints out, I will not print. So this is a new nifty way to say if you want to always do something first before doing any evaluation, you can flip a while statement around to be at the end. So normally we put the while loop first, You can use the do statement to make it run something and then check the condition subsequently. All right, let's try an example. We'd like to program to simulate part of the cake baking process. Depending on the recipe, a different number of cups of sugar is required. Create the variable, let cups of sugar needed, and assign it the number of your choosing. Well, I like sweet, so we're going to have 15 cups of sugar. Seems healthy. The cup of sugar must be added to the batter one at a time. Declare the variable cups added, assign it the variable 0. All right, run. Good. We have a sweet tooth, so we want to add at least 1 cup of sugar to the batter, even if the variable of cups of sugar needed is 0. It's a lot of extra sugar. Create a do while loop which increments cups added by 1 while cups added is less than the cups of sugar needed. In order to help visualize the output on each iteration of the loop, add a console.log within the do while block and log the value of cups added. Okay, so it's saying even if we don't need any sugar at all, we're still going to do it once. That's a good indication we need a do while loop. So do something. We're going to take cups added and add 1. How often are we going to do that? While cups of sugar needed. So what are we comparing to? We want to say our cups added is less than or equal to the necessary amount. Right? As a result, this will keep looping until the cups added gets to 15, because 15 will be equal to the cups of sugar needed. In order to see what's happening, though, they want us to console.log. So console.log added, we can print out something. Cups added. Cups. So we added 1 cup, 2 cup, 3 cup, 4 cup, 5 cup, all the way, we got to 16 cups. We did it wrong. Remember, you don't want to have it equal to. It needs to be less than the cups of sugar necessary. See? Why? Because remember, everything's a little backwards now. With a do statement, it's not going to evaluate until the stopping condition until after it's already run. So we need to make sure that it's less than the cups of sugar necessary. It's a little bit backwards in a lot of people's heads, so give it some practice today to make sure you understand it. If you said cups of sugar necessary is 0, watch what happens. It still adds 1 cup, right? Because it's going to evaluate the do statement first, where it always adds a cup, even if 1 is, not less than 0, it's still added that 1 cup. So you're going to end up with a very sweet cake. All right, the break keyword. Imagine we're looking to adopt a dog. We plan to go to the shelter every day for a year and then give up. But what if we meet our dream dog on day 65? We don't want to keep going to the shelter for the next 300 days just because our original plan was to go for a whole year. In our code, when we want to go to stop a loop from continuing to execute, even though the original stopping condition we wrote for our loop hasn't been met, we can use the keyword break. The break keyword allows programs to break out of the loop from within the loop's block. Let's check out the syntax of a break keyword. Imagine you're looping from I equals 0, where I is less than 99, we increment by 1. But if we get to I is greater than 2, just break, give up, and then console.log banana. And then the joke is, aren't you glad I broke out of the loop? Sure. Let's give it a shot. If you were to run this, then we can, you'll see banana, 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 aren't you glad I broke out of the loop? Because it starts at 0, that's the 0. Then it gets to 1. 1 is still not greater than 2. Then it gets to 2, but at 3, the third iteration, 3 is greater than 2. Break, it's not going to print banana that fourth time. Therefore, we're going to break out. And then it says, aren't you glad I broke out of the loop? It's quite useful. All right, let's try the example they give us. Log each element from wrapper array in a for loop from using the iterator variable I. So for wrapper array, well, maybe what we'll do is let I equal 0, where I is less than the wrapper array dot length, I++. That will iterate over the full array. And it wants us to log each element, so we'll do a console.log on the wrapper array at position I. Little Kim, Jay-Z, Notorious B.I.G., Tupac. After the for loop, log the string, and if you don't know, now you know, to the console. Note, there's a single quote character in our string. We can use the double quotes around it to ensure character prints. All right. After the for loop, log the string. So console.log we put inside here now what you want to print out. Now remember, you'll see that don't has a single quote here. If you run this, watch what happens. It works fine, but if you accidentally put in single quotes, well, you're going to have a syntax error because it's going to go from here to here, and then it's going to think that's the end of the string, and then it doesn't know how to evaluate the rest of this. So the way to fix it, easily at least, is to use double quotes. That will allow you to capture the single quote correctly. All right, we've completed that. Okay, they want us to change it now. Add a break inside the loops block that breaks out of the loop if the element at the current index in the wrapper array is Notorious B.I.G. So put it at the beginning here. If wrapper array at this position equals notorious, notorious. All right, B.I.G. Then break, run. As you can see, when it hits Notorious B.I.G., we get to the break statement. It does not print out Notorious B.I.G., at which point, and if you don't know, now you know. Although I forgot to log it, so I guess what they really wanted me to do was actually continue to print Notorious B.I.G. So we'll switch it around. Run it again. Now it's correct because it wants us to print Notorious B.I.G., so always print it out first. Then once we hit Notorious B.I.G., if you don't know, now you know. That's it for today. I hope that covers enough to give you guys an introduction to loops. We've not gone deep into any of the Solidity code, but I want you to see what we just covered in JavaScript is identical. Look at the for loop in Solidity. For, now instead of being able to just call a let, you have to declare what type of variable in Solidity we're dealing with. In Solidity, you'll see things like uint, like an integer. Integer index I equals 0, while I is less than some C token count. C token count is, well, it's up here. C token count is the length of an array of tokens, C tokens. It's an array of tokens, I++. Add 1 to I each time. Each time, call this C token metadata function. The C token metadata function, well, you pass in a C token. So we pass in C tokens at position I. That'll give us 1 token. It's going to run all this garbage and spit out all of this information about the token, which then gets stored into a new array, which is going to keep track of all the metadata information about all the different type of tokens in the compound. Same concept, nearly the same implementation between JavaScript and Solidity. So by learning some JavaScript here, I think you guys can see this type of concept plays out in just about every programming language, including smart contract development. And it's a very useful one when you want to iterate over a large amount of data, like in the case of a DeFi application compound, which has many, many different tokens they have to support with a lot of information about each token. All right, that's it for today. I'll stop the recording, but we'll stick around here. And if you guys have questions, we'll take time for some questions.